Hi there, completely different location this time, but you can do math everywhere, and there is always time to do good math. In this case, electrical engineering. So I'm going to continue my lectures about, well, not just lectures, they're actually very simple examples, not proper lecture. But anyway, I'm going to continue those things about body plots. So let's start, let's crack on and start with something like our new function h of s. And this time we're gonna have s squared plus 20s plus 400, everything over 100 times 1 plus s. So in this case, the first thing that we're gonna do is to normalize it. So basically we're gonna have we want to have everything done in terms of 1 plus s. So at the bottom everything is fine, but at the top it isn't, because we have 20 here and 400 here. So we don't want to have this one here. So we're going to multiply everything times 100, and we will have 1 plus s over 20 plus s squared over 400 times, oh well, no, yeah, already right, times 100, everything over 100 times 1 plus s. So essentially 100 and 100 simplify. So what we end up with is 1 plus s over 20 plus s squared over 400, everything over 1 plus s. So now, as I did before, I can say, okay, let's let s equal to I omega. So we no longer have h in terms of s, but we have h in terms of I omega. So I omega, which gives us 1 plus I omega over 20 plus I omega squared over 400, everything over 1 plus I omega. So I don't like to write this way. I'm gonna bring the square one level up. I'm gonna write 20 instead of 400 at the denominator. So essentially we're gonna have 1 plus I omega over 20 plus I omega over 20 squared, everything over 1 plus I omega. So just like before, this big guy here is going to be our 0, and this guy at the bottom is going to be our 4. Now I'm going to bring everything into decibel, and I'm going to analyze each and every component individually. So I'm going to start with the pole, so with 1 plus I omega, because it's the easy part. So if I bring everything into decibel, I'm going to have to do 20 times something, so 20 times the log of something. So it will be 20 times the log of the Euclidean type 2 norm of this guy here. And since it's a pole, so it's basically sitting at the denominator, I'm going to have a negative sign in front of everything. So negative 20 times log of the Euclidean type 2 norm of this guy here, so 1 plus I omega. So this will be negative 20 times log. So the Euclidean norm is just of the complex number, just the first square plus the second square. So essentially will be 20 times negative 20 times log of the square root of 1 squared plus I omega squared. Just put it. Whoops. Something in my notes I corrected it. Okay, so this is negative 20 times log of the square root of 1 plus omega squared. So essentially, well, yeah, that's pretty much it. So now I'm gonna rewrite this. It's negative 20 times log of the square root of 1 plus omega squared. I'm going to do exactly like in the other videos. So I'm going to say, okay, if omega is equal to 0, so this part, this omega here is equal to 0, then we're going to have the square root of 1. So what we are left with is negative 20 times log of the square root of 1 plus 0. So negative 20 times log of the square root of 1. But we all know that the square root of 1 is 1. So negative 20 times the log of 1, because the square root of 1 is 1. And as always, we all know that the log of 1 is 0. So negative 20 times 0 is 0. Now, if omega is way bigger than 1, then we're going to have negative 20 times log of, well, it's way bigger than 1, so it's something really, really huge, squared, plus 1 in just this one squared. So the square root of this one is just this one. So negative 20 times log of omega. Now it's time to plot it. And in order to plot it, well, it's actually pretty easy to plot, to be fair. So let's suppose that, I don't know, around here is 1. So nothing happens till 1. At 1, it's a pole, so it has a negative sign, so it goes down. Just like that. So we are expecting something to do this for this part. Okay. So you should be pretty familiar with all this by now. Okay, let's crack on and go on with the less easy part, which is the 0 here. So this all big guy here. So let's just write it. Oops, there we go. So this one here is a 0. This whole thing is a 0, so we don't put a negative sign on top of everything. And we just write 20. If we bring it into decibels, so it's going to be 20 times log of the Euclidean norm of this whole thing. So it will be 20 times log of the Euclidean norm type 2 of 1 plus I omega over 20 plus I omega over 20 squared. Now, we can compute this norm, but those are complex number will be actually difficult to do so. So we just go straight to the if. So if omega is equal to 0, well, what do we have? Well, we're going to end up with 20 times log of 1, because this guy here will be 0, this guy here will be 0, and all we're going to be left is going to be 1, so 1. But the log of 1 is 0, so it's 20 times 0, which is 0. That is surprising. Now, what if omega is way bigger than 20? Well, so way bigger than 20. Well, this is squared and is competing against this guy here, but this one wins because it's the dominant part. So what we're going to be left with is 20 times log of I omega over 20 squared. So this is 40 times log of omega minus negative, so minus 40 times log of 20. Now, the important part in this case is this 40 on top of everything, because this 40 here is actually telling us that although this is positive and this is a 0, so it's going up with a different slope. Is the going up with the steepest kind of slope compared to this one, because this one is going down like this, but this guy here is not going up like this, it's going up like this. So it's this guy here is going up in a stronger way than how this is going down. So if I had to plot it, I will plot it like so. So if this one is 1, let's just put 20 like here. So with this one, this guy here is 1, this is 20, so nothing happens till 20, but at 20 we go way up. So you can see that the slope of this one is different from the slope of this one. So we are expecting nothing to happen, nothing till here, when it goes up. Now, I found both of them, so those two, which result in those two graphs in my body plot. So I'm ready to draw my final body plot, which is the sum of those two graphs using the superposition of effects. So, which I told you was going to be extremely useful. So now, my final graph will be, well, I'm gonna have 1 here, something like, let's put 20 here. So what happens till 1? Well, both our graph were just flat till 1. So this one is flat, this one is flat, this one was flat till 1, this one was flat till 20. So at least till 1 nothing happens, so everything is flat. Now at 1, this guy here is gonna try to bring everything down, so it's just gonna go down till, of course, till it meets 20, because the contribution of this one is just go down, and the contribution of this one till 20 is nothing, just go flat. So the result is go down. It's gonna go down. Let's try it till here. Okay, so now that it's gone down at 20, this one still wants to bring everything down, but now it can't do that anymore, because at 20 this one pops up and it tries to bring everything up. But I said, remember this term, this 40 here, in front of everything, is stronger than this negative 20. So this one is gonna go up anyway, because it's gonna, win against this one. Therefore, in our graph from here, from 20 on, is gonna go up. up till infinity potentially. Now we are halfway through because this is fine, but we have only been dealing with the gain and not with the phase, so not with the angle. Now we're gonna find the angle, so the phase graph of I omega in terms of I omega. So if we remember, let's start with this one again. Let's start with the pole because it's the easiest part. It's the easier part. So 1 over 1 plus I omega. Our angle here, well, we're going to study the angle of 1 over 1 plus I omega. And I'm basically going to multiply by the complex conjugate up and down. So times 1 minus I omega over 1 minus I omega. It's going to give me 1 minus I omega over 1 plus omega squared. So now I'm ready to calculate the arctangent of this guy here. And if you remember, we do the arctangent of the imaginary part over the real part. The imaginary part is omega, the real part is 1. So we do the arctangent. Well, after arctangent, I don't know why I always want to put the G. Anyway, the arctangent of, well, negative, because we have a negative sign here, of negative omega over 1. So I can use the property of the arctangent and bring this negative in front of everything. So negative the arctangent of omega over 1. I can plot it. So essentially, the arctangent of this thing, sorry, I got cold. Don't worry, it's not a virus or something, it's just that I got cold because it's winter, outside is cold, and I should cover myself much more. But anyway, let's go on with the important stuff, which is this Bode plot for the phase diagram. So up till 1, we're gonna have what do we have? We have here going down till here, where we have 45 degree. Well, negative 45 degree. Now I'm gonna go on with the other guy, the monster guy, which we have as 0, so this whole guy here, and find the angle, so the phase diagram. This guy here is 1 plus I omega over 20 minus omega squared over 400. So if I take the arctangent of all this, it's a mess. So the arctangent of this will be omega over 20 over 1 minus omega squared over 400. So the imaginary part over the real part. This is the imaginary part, and these two guys are the real part. Now we do have a problem, because if we have a singularity point for omega equal to 20, because if we put omega equal to 20 here, we would have 20 over 20, we simplify to 1. Here we would have 1 minus 20 squared, which is 400. 400 over 400 is 1. 1 minus 1 is 0, so we would end up with 1 over 0, which is not acceptable actually. So we do have a singularity point. In this case, when we do have a singularity point, we study, just like before, we study the function when it's greater than 20 and less than 20, on top of the other on the other point when omega is equal to 0 and so on and so forth. So let's start with the easy part. For omega equal to 0, what do we have? Well, we have the arc tangent of 0 over 20, 0, 1 minus 0 square over 400, so over 1 is 0, so this is the arctangent of 0, which is essentially 0. Now, since we have a singularity point, as I said, for omega equal to 20, because we would have a 0 at the denominator, and that's no good, we're going to study for omega greater. Well, let's start with less than 20, and then greater than 20. So for omega less than 20, we have the arctangent of omega over 20 over 1 minus omega squared over 400. And for omega greater than 20, we have the same thing, so the arctangent of omega over 20 over 1 minus omega squared over 400, but this time we're gonna add pi, because as I said, the function is gonna jump, just like I showed you before. The function is going to jump. Whoops, I'm gonna use another piece of paper. Okay, let me see if I can just, okay, that's good. Okay, so now in my graph, in my phase diagram, whoops, there we go. In my phase diagram, in this case, I'm gonna have 20 here and 400, which is not in scale, but who cares? I'm gonna put it here. And essentially what's gonna happen is that we're gonna have, it's gonna grow up till 400. So let's see if I can just draw a straight vector till there. Yay, straight line. And a 20 is gonna go up. There we go. Just like this. And here is a midpoint at 90 degree. Here is at 180 degree. Now, if I'm gonna sum those two graphs, so this one with this one, oh, you see nothing here because of the uncontrolled, unpolarized light. Yeah, sorry about the sensor. Anyway, if we're gonna sum this graph here, and you're not gonna see anything anymore. Yeah, oops. Okay, with this one, what we're gonna end up with, thanks to the superposition of effect, will be this graph, in which, well, we will have 10 here, 20 here, and 400 here. And essentially, this one wants to go down, and this one wants to go up. This one is down at oh no, what, yeah, oh, no, it's this one, yeah, it's correct. So this one will go down till negative 45 degree, and this one will go up. So essentially nothing is going to happen till 20. I can draw one, but it will be pointless. Nothing gonna happen till 1, nothing gonna happen till 20, nothing till 10, nothing gonna happen till 20. But at 20, then this one wins, because it goes up to till 180. But since this one wanted to go down, then it's gonna go up, but not as high as before. and it's gonna go up till here like this, but this one here is actually is no longer 180, but this time is 90°. So yeah, this is pretty much it for our body plot, both the gain plot diagram and phase diagram. I hope it helps, just like always.